Hi everyone, and welcome to today's Ask Tom Live. Today we're going to have a schema showdown. So we're going to be discussing various ways you can design a database schema and voting on the choices. So what we're going to do is imagine we're recording data about weather, right? I'm just saying it's quite cold here in the UK at the moment. We're going to have various weather sensors to capture information about things like the temperature, wind, rainfall, and so on. So there's a few things that we're going to need to do, a few use cases. Obviously, we need to be able to insert our new temperature readings. We also want to be able to delete them as well. So that's something important to think about as we go through this. We want to calculate things like running totals and averages. So quite often you kind of want to smooth the data a little bit. Things like the temperature, you want to get the running temperature, average temperature over the last 15 minutes, hour or something out, just to smooth out if there's any been any large variances or misreadings in your sensor. We want to find the second between readings. We're expecting readings like roughly every 10 minutes, so 600 seconds, but there might be some gaps between them. Occasionally, we might lose some values and stuff. So we want to be able to calculate the time difference between each reading in seconds. And finally, we will need to do some kind of conversions, right? So those of us over in here in Europe, or in fact most of the world, will usually use Celsius for temperature, whereas in the US, people typically use Fahrenheit. So we'll need to do some kind of um, unit conversions. Celsius to Fahrenheit is the most common, but we might need to do, meters per second of rain or millimeters per second of rain to inches and things like that as well. So those are the use cases to kind of have in the back of your mind and think about as we go through our showdown. So basically, we're going to building a schema, create the tables to store this information, the weather sensor information. Um, I'm going to present some choices that we need to make. We'll have a discussion about them. Please share your thoughts. Let us know in the comments what you think is the best option in each case. And then we'll have a vote. We'll vote live on it, and I will then build the schema based on your choices. So you really get to influence how the session goes today. So please get involved and let us know what you think. So before we get into that, hi everyone. I'm Chris Saxon. I'm part of Gerald Venzel's app dev team here at Oracle. I'm here to help you get the best out of Oracle AI database and hopefully have fun with doing so. So, like I say, with that in mind, it's always great to be here for these Ask Time live sessions. Before we get into those, some kind of fun SQL games that we created on Oracle Dev Gym. Good way to kind of practice your SQL skills. We've got Speed SQL, what we're calling. Basically, it's kind of a race against the clock. You've got 60 seconds to guess the missing keyword from 10 SQL statements. So here you can see we've got something, 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 max, blah, 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 blah. And you need to figure out, is it sort, compress, select, unused? You'll click the one you think is correct. The next one will flash up, and you've got to kind of get through them all, get them all right in 60 seconds. Can you find them? You can try as many times as you want in the day. Each day will reset at midnight UTC. Will issue a fresh batch of statements for you to guess what they are. We also have Squizzle. So this is like SQL Wordle. I think many of you have either played or at least seen Wordle, the kind of guess the word quiz. We're doing something very similar with Squizzle. So today we've got a SQL statement you need to guess. It's something West End shows, and then some other parts here. So we've got SQL fragments below that you can use to complete the SQL statement. And basically, you've got to see if you can get it in 6 tries or less. A bit like guessing the word in Wordle. So again, we're going to have a new statement for you to guess every single day. So it's something you can just come along, play for free, practice your SQL skills while you have a cup of coffee or whatever. Moving on to today's session, like I say, we are going to build the schema, going to run the demo here, and it's going to be running on Oracle AI Database 26 AI free. So this is the free version that you can download, run on your laptop, your machine, and use for whatever you want. Right, I'm going to run everything on that. Now, at this point, some of you might be looking at this and going, hang on a second, Oracle AI Database 26 AI, what's going on? I thought we were on 23 AI, right? Well, This is something that was announced at AI World, was it last month? Yeah, last month in October. So a year and a half ago, we released Oracle AI Database 20, Oracle 20, 23 AI, right? Um, we have the quarterly release updates. If you apply the current release updates, the October 2025 release update to 23 AI, it automatically becomes Oracle AI Database 26 AI. So 26 AI replaces 23 AI. If you look in the docs and things like that, you'll actually not find any references, or you shouldn't find any references to Oracle Database 23 AI. So basically, you just apply the release update, and this is what you get. If you want to know more about this and just kind of see what features are there and what's come, I'm going to be talking all about it in next month's Ask Tom Live. So I'm going to go through some of the cool SQL features and other developer related features in AI database. So again, in its usual time, 2 p.m. on Tuesday, we're back to the usual kind of third Tuesday of the month. We've been a bit out of sequence recently because I've been at DOAG and AI World and other conferences. So back to our regular scheduled slot next month. So if you want to know about 26 AI, come join me next time. All right, all that out of the way, let's get back to the showdown. Let's get back to kind of deciding what's kind of schema we want to build. So, like I say, we are going to be capturing weather sensor data. And one of the attributes we're going to have is the time that the recording was actually made, right? The date time that we captured it. So there's two kind of core data types we could use here in Oracle database. We can use a date or we can use a timestamp to record that. So at this point, kind of let us know what you think. Which arguments for or against using a date or using a timestamp to store the date time that we get this sensor information. Basically, we're going to collect it all in, we'll store in the database what time that reading was actually made, and we need to decide whether it's a date or a timestamp. So, I want you to kind of, we'll have a vote in a second over what you're going to choose, and but why would you choose date or why would you choose timestamp? I think that's really what we want to get into here is like we're going to pick that. I'm going to put a poll up in a second and we'll see that. So we see you've got some comments coming in. Yeah, it depends on the granularity that we need, but probably date would suffice. Okay. Data's granularity might be only needed at second level. Okay, so this is a good point, right? With dates, it goes to the second. If we need fractional seconds, we have to use a timestamp, right? So there's an interesting question, an unresolved ambiguity there. What precision do we actually need? So comment, timestamp could be relevant if we get readings from different time zones and need to consider the calculations. Great point there. Timestamps can include time zone information. Dates cannot, right? You can't have a time zone associated with a date. You can have a time zone associated with a timestamp. Yeah. So date is enough if we have 60-second, we just need second granularity and we don't need time zones. So yeah, there's good comments here. Doesn't date also store the basic timestamp information internally? I'm not sure what you mean by basic timestamp, but it doesn't have any time zone information. The dates do not have a time zone, right? You have to kind of know implicitly what time zone the values are in. Okay. Usually the best way to do this, the usual way, is to use UTC and just store everything as UTC in the database. But there's literally, you cannot associate it. You have to kind of infer it from other information, maybe another column if you want time zone information. Okay. Interval arithmetic is easier with timestamps. This is another good point, right? They actually have slightly different arithmetic. Yeah. Subtract a date from a date and you get a number of days difference between them. So just a number. Timestamps, on the other hand, you subtract a timestamp from a timestamp and you get an interval, which is a specific type for recording durations. So, we were having to ask, we wanted to calculate time differences in seconds and things like that. Is that easier with a timestamp or a date? What do we think there? Um, I see if you if you put your hand up, just let us know, like say in the Q&A or the chat, what you think. We're not gonna have unmuting people here. See what they think. Funnily enough, our JSON interface wants a time zone, so we need to convert to UTC also. It's a puzzle anyway. It's always an interesting thing, working with time zones and UTC and things like that. What do we use? Which time zone it is? They say generally, I think the usual way is just store everything in UTC, and then convert on the client if you need to. But sometimes the time zone information is relevant. Something like this, it probably isn't, or we probably don't need to know which time zone the sensors were in. We could figure that out from their location or something like that. But it's a good point. Seems to me that when working with data, it works faster in where conditions than with timestamp. Is this nonsense or could it be so? I've I don't know of a reason why date would be faster than timestamp. It might be something like, because they are different data types slightly, you might have some implicit conversions going on, which stops index usage or something like that. And it's not really that date is faster than timestamp, it's just you get a different plan. But I don't know of a reason why date would be faster to process than timestamp. Certainly not in a way that you would notice in real queries, right? Maybe there's some kind of microsecond difference, but the chance of you noticing that is pretty slim. Okay, so we've had some various comments things in. So we've had quite a few comments. So I think at this point I'm going to start the poll. So hopefully you can see the poll on Zoom. So start putting your votes in. And we'll see what people go for. Feel free to kind of keep making comments while that goes in, and we'll do that. So, do. Okay, I can see the votes going. It's kind of close. It's closer than I thought it may be based on some of the comments, although it's switching a bit. Um, there we go. I think still a few people to vote. I'll give you a few more seconds, see if there's any other questions or comments come in. I think we've covered most of the key points here on date and timestamp, but certainly all the points that I'm aware of. Okay, so I'll give you, we're up to 50 seconds. I'll give you another 10 seconds so we get a full minute to actually vote. I think we've got most of people coming in at this point. All right, so that's the minute. Okay, so we'll end that and I'll share the results. Hopefully you can now see 60-40. So 60% of you went for timestamps, 40% went for date. I'm going to write that down, make a note of this as well in case I forget halfway through. But we're going to go for timestamps there. Okay, so I thought it was going to be date actually, based on the initial comments, but timestamps it is, but it was kind of close there, right? And as you say, there was various things which were kind of undefined. What precision do we need and things like that, which might affect our decision in the real world. All right, let's move on to the next requirement here. So next thing we want to look at, I said we want to insert stuff, duh, right? We need to insert data, but we also want to be able to delete data. So we might need to wipe out a whole sensor. So we've got a sensor, like a, parent-child relationship. Each sensor could have multiple, well, hopefully we'll have lots of readings. So the question here is, we've got foreign key from each recording we make against, each value, temperature, whatever we get for that sensor, and foreign key to the sensor itself with metadata, like where it is and stuff like that. So for that foreign key, do we then have to handle delete manually? So if we need to delete a whole sensor, do we have to manually delete the child and then delete the parent ourselves? Or do we declare the foreign key as on delete cascade so we can just delete that parent sensor row and the database will propagate it down to the child table? So we add this on delete cascade clause. What do we think here in terms of what we're going to go for? So basically, the question is, we've got parent-child relationship, we've got a foreign key from the child to the parent. We want to delete the parent row because of that foreign key. If we do that, we'll get the foreign key. You've got child rows exception. If there are child rows, do you handle the deletions manually? Do you delete from the child yourself and then the parent? Or do you make an on delete cascade foreign key so as soon as you delete that parent row, the database handles it for you? What about on delete set null? Well, that's a good question here. So there is another option we could go for. You can say on delete set null. What this does is we've got our sensor ID column in the child table. We delete the parent row, it will set that to null. We could do that, but then we've got a whole bunch of sensor readings which are unrelated to anything, right? We've got a bunch of orphan rows. There are scenarios where that might make sense. Let's just say in this situation, the reason we're deleting a sensor is because we need to kind of get rid of it. There's some problem with the data. We've got to like GDPR compliance, I don't know, something like that, some cleanup. Point here is we have to delete all the data related to that particular sensor, right? So on delete set null won't really help us here in this situation, but it's a good point. It is something that could work in some scenarios. Okay, so I see the comments coming on. Probably on delete cascade will be preferred, especially if you want to use things like reference partitioning. Yeah, that's a good point actually. So as you're not familiar, reference partitioning, hopefully most of you are at least kind of familiar with partitioning. Split a table up into separate, physically split it into separate tables by logically keeping it as one table effectively. Reference partitioning allows us to kind of copy the partitioning scheme from the parent to the child, and then that can be quite useful for deleting them if we need to do that. But yeah, something to consider. I'm a bit torn here. On delete cascade provides convenience, but from a purist point of view, I can see why no action makes sense, right? Yeah, well, that's the debate here, isn't it? Are we going to be purity or are we going to be practical? Um, okay, good question. Right, since it's not a few child rows like in order entries, I would not delete cascade the delete. We are probably deleting millions of rows and want to handle that separately for performance reasons. Maybe postpone it to the night. Depending on the number of sensors, it might be feasible to partition based on sensor ID, though. That's a good comment, actually, right? Like I say, we're expecting readings every 10 minutes. So what's that? There's going to be a few hundred rows per sensor per day. That's going to rack up fairly quickly, right? So if it turns out after a year we need to wipe out a whole sensor, that's several thousand rows, possibly getting to a few million. Yeah, deleting lots of data like that can take a while, and we might want to optimize itself. There's lots of ways you can optimize a delete. Talk for another day, right? But it's a good point about the performance aspect here. We're probably going to have lots of child rows for each sensor, or worst case, we will, right? So we might need to consider that. On delete cascade, of course. Of course, why? Why, of course, right? Um, okay, depending on the amount of data, partition is also possible. A few of you mentioning partitioning. I mean, we're probably going to have lots of sensors. It's unlikely we will have one sensor, one partition per sensor. We might do, but we probably won't, right? I mean, the advantage of we had one partition per sensor, we could do things like drop partition. I guess this is where what a lot of you are thinking, other people mentioning partitioning. I would say in the real world, you probably wouldn't have a partition per sensor. You might, but and in which case you wouldn't be able to just do things like drop partition. Yeah, it's a consideration, right? It depends, right? Okay, it depends. What does it depend on, right? Why does it depend? Okay, this is what the debate is. What does it depend on? Why? Let's have a think. What will we go for here? There's no single answer to this. Come on, pick an answer. Give your reasons, right? It depends on the data retention requirements. Why does it depend on the data retention requirements? What about them matters? Okay, but I mean, these are all good points, right? These are all questions you need to ask before you design the schema and pick an option here. But what are the questions you're asking? How do they influence your decision? How do they sway you one way or the other? right? I'm deliberately keeping things kind of vague to kind of so we can think about these things a bit here. But even with on Cascade, you always choose to delete child records first, isn't it? You don't have to. I mean, you can choose to. That's correct. But the point of undelete Cascade is we can just delete that parent row, and the database will handle it for us. We don't need to think about it. Okay, that's probably the big advantage of undelete Cascade. If you want to manually delete the child records first for performance reasons or whatever, you can. So these aren't necessarily mutually exclusive options, right? I guess if we've got no action though, you have to manually delete them. Whereas if it's on cascade, you can let the database do it for you. I say this is more for the UI than data model. Well, I don't know. I think people have raised some good points about why it might be good for the data model, like performance and things like that, not just a UI consideration. All right, so I've started the poll. We've had a lot of things come in. Um, okay, we've got the votes coming in. So we'll leave that up for a minute or so. My point was in response to deleting a large number of records as an argument against on Cascade. Right, yeah, yeah. As I say, someone said you might avoid on delete Cascade for performance reasons. So you can, I guess the trap here is if you have got it on delete Cascade, you might issue a delete from that parent and not even realize you're about to delete millions of rows, right? Um, so there's if you know what you're doing and you're thinking about it, yes, you can prepare and do it manually. But if it's on delete cascade, the database is always going to remove them for you. Whereas with no action, you always have to do it manually. So, fun thing to think about. All right, I think we've got most. Why would on delete cascade be less performant than a manual delete? Well, generally, if you're deleting lots of data, the fastest way is to not delete it and do something like create table as select or there's lots of tricks to remove data that aren't actually deleting it, okay? And the database won't do those if it's on delete cascade. So the you can't the database doesn't have the won't take those tricks for you quite often because they're multi-step and things like that. Things like a filtered table move. There are DDL tricks you can do to delete data that aren't actually delete statement, which could be substantially faster than deleting lots of the data. So someone exactly, I'd be afraid to set on delete cascade. I want to see the code. On delete could be overlooked. Maybe. Yeah, that's the thing. Maybe you don't realize it's cascading and you accidentally delete something you didn't mean to. Um, when you trigger a delete with a REST call, Cascade could cause timeouts and errors. Ooh, that's a good point. Filtered table move is awesome. That was good to hear, right? To reduce the amount of manual work, we should let the database handle what it can. So in most cases, we'll use Cascade. If there's situations where deletions must not be allowed, then we'll block it when a child exists. I mean, you're kind of represent building your own foreign key at that point. So, yeah, it's things to think about. Right. I think most people have voted in at this point. I'll give it another couple of seconds, but they say seems like a simple choice, this, right? But we've brought up lots of options or lots of things to think about why we would choose one or the other. All right. Final seconds. Okay. 5, 4, 3, 2, 1. All right. Okay, so we'll end that poll, and if I share the results on delete cascade, I wasn't sure which way this would go, but 2/3 of you going for on delete cascade. Okay, so that's something a bit different. I again, I thought it might be manually, but oh wow, you've surprised me there, folks. Okay, so but like I say, there's lots of things to think about here. About in terms of what performance do we want, what behavior do we want, how does this impact UI and things like that. Okay, so let's move on. So we got on delete cascade. That's what we chose there. I've written it down so I can remember. All right. Next, calculated columns. Right. So I mentioned we'll want to do like unit conversion. Probably the most obvious is Celsius to Fahrenheit, because most of the world uses Celsius except the USA. But there's probably other unit conversions that we'll want to do. We're capturing things like rainfall in millimeters a second. We might need to convert that to inches, things like that. So we can do this as a virtual or a materialized column. So we're going to have these as columns on the table. Now, materialize is something very new, so I just want to recap and cover the differences on these quickly, because virtual columns have been around quite a while now, so 20-ish years. They were introduced in 11.1. We add a column to the table, which is that expression, that formula, and it's calculated when we query that table. So whenever you access that column in a query, the database runs that calculation, and it's only storing metadata. It only stores that formula, so it doesn't actually use any space. Materialized is the new kid on the block, introduced very recently, 23.7, so just a few months ago. This is calculated on write. Whenever we insert or update the associated columns in the table, the database will run that calculation and store the result in the table. Okay. However, what this means is when we query it, the result is already pre-calculated. So are we calculating on read or calculating on write? So what do we think? What are we going to go for here? Which will we prefer? Virtual columns or materialized for these kind of calculated columns? Like say, let's assume we're capturing temperatures in Celsius, but we also want to show them in Fahrenheit for the people who don't use, um, the kind of, uh, metric measures, right? Okay, come on. It's going to be worm. Write once, read many system, and the data comes in every 10 minutes. So we have enough time to calculate and store the result. This improves the readings very much. So I guess that's an argument of in terms of materialized. I say we're going to insert the data. We're probably never going to update it or change it again, right? Probably. So but we will query it like who knows how many times, hundreds, maybe even thousands, depending on who's using this data and what for. So yeah, it probably is write once, read many. I would expect that from this kind of system. Yeah. Data is write once, but read very often. So materialize. Yeah, same comment, right? Um, if fast inserts and much data is more important than virtual, otherwise lots of reads expected than materialized if space permits. So that's a good point, right? We're going to write once and read lots of times, and I've said we're going to have sensor readings every 10 minutes, but how many sensors have we got? If we've got millions, maybe even billions of these sensors, we might still have a lot of inserts happening at the same time. So even though it's write once, read many, we might still need really high through insert performance. Right. So another kind of consideration here. I think the calculation is simple enough that it's not affecting the performance of aggregations, but I would still go for materialized because we read far more than writing. Yeah. I mean, it is just like a multiply or plus and divide, which I forget, multiply, divide, and plus, right? Celsius to Fahrenheit. It's like 5/9 plus 32, something like that, whichever way around it is. But it's a fairly simple calculation. That is a good point. It's not like we're doing something ultra complicated. But this is just one. What if we have loads of these? What if we have to convert millimeters to inches or something like that for rainfall, things like that? What about calculated columns that depend on another table's columns? I mean, denormalized columns. What would you recommend in this particular case in order to improve query performance? That's a good question. So just kind of clarify here, all the data we need to do this conversion is in within the row in the same table, right? We have the same temperature in Celsius. It's just a simple formula to convert it into Fahrenheit. So we don't need to cross tables. Some situations we might need to do that. We might need to cross tables. In those situations, materialized views are the things I would look at. But yeah, it gets a lot more complicated. Maybe we can have a debate about that in the future at some point, which to go for. Uh, I feel in the UI would need to be able to handle inserts in Fahrenheit. I would do neither and handle it in the UI. Ooh, that's a interesting, a fair point. One way of doing it. I I've assumed kind of constant units for the temperatures. I said we're always going to get them in Celsius. It's possible we won't, right? It's possible we got sensors that work in different units, in which case we'll need to handle it. We'll need a value, and then the units it's for. Let's keep things simple for now. Let's just assume we have got constant units for our sensors. They're all from the same manufacturer, so they all support the same type of units, so we don't need to worry about that. But it is something that in a more general system we would need to think about, right? How do we handle different current the different units there? I think in memory does have some performance enhancements for virtual columns, so this favors virtual. I mean, I think so. I'm not too familiar. I think you're right for in memory, but also, are we going to load this in memory? Are you favoring virtual because in someday we might load this in memory? Is that make sense? I don't know, right? I mean, if you are using in memory, obviously it is definitely a consideration. But should we plan and build something just because we might use a feature at some point in the future? Don't know, right? All right, so we've had some comments come in. I've launched a poll. Like I say, feel free to add more comments while you vote. So we'll let the votes trickle in, see if there's any more. I think in memory loads then reuses the calculation results. I mean, I think you're probably right, but that's kind of with materialize, we save having to do that calculation at all, right? Because we've already got the results. So maybe that's an argument for materialize as well, because it saves in memory a bit of work, having to do a bit of work. I don't know. There'll have to be some place where we decide what a specific user wants to see. In that moment, we could do the conversion. I can't really see the advantage of having it in the table. Um, well, the advantage of doing it in the table is that we've got that calculation in one place, right? Yes, you're right. We might need to show it to different users. Some people might want Celsius, some people might want Fahrenheit. We could do that on the fly, and actually, that's what virtual is really, doing it on the fly. But we don't need to repeat that formula. You don't need to worry about someone screwing the formula up and doing it wrong because they used a different app or wrote the query wrong, or having different precision for rounding, right? Maybe we'll always round to one decimal place and someone forgets or doesn't know that rule and rounds to 10 decimal places. By having it in the table, it's one consistent place for it. Plus, when it comes to the calculation, by materializing it, we're calculating once. No one else has to actually run the formula again. All we're doing is selecting which column we need to see. But it's a good point. Good point. Right. It is something to think about, right? You've got a good point as well. What people need to see, how and where we do that calculation is something to think about. Another argument for using virtuals, who knows what all the side effects are of a new feature. I mean, if we start saying that, we'd never use any new features ever, right? Ultimately, you've got to start using things at some point. Okay, so I think most of the votes have come in at this point. I'll give you a couple more seconds to let the results come in. Okay, so here we go. Do the timer countdown. Boom. And end the poll. And actually, that ended up a lot closer than I thought that it would be based on the original comments and votes. So we got materialized slightly edging it out, just under 60-40 vote to materialized. Um, what happens when you update a column that's materialized? Okay, so you cannot update the column itself. Okay, so we've got this temperature in Fahrenheit. You can never change or set that value directly. If we update the value it's derived from, the Celsius, then it will recalculate. So it's all inserts or all inserts that aren't null, I guess, and all updates of the columns used in this materialized expression. Okay, so those write statements will do that. But you cannot set it directly. You can't write an update to change the value of a materialized column. Only the database can do it. Okay, it's materialized. All right, so we had materialize win that. Okay, so let's just stop sharing and we'll go on to the final vote here. So probably the most interesting one, I think. And this is optional values. Basically, we're going to capture three types of weather data: heat data, so temperature, pressure, that kind of thing; wind data, wind speed, wind direction, and rainfall. Okay, so we've got these three types of sensors or three sensors. Now, each sensor or each location could have one of these or all three of these. But the point here is if we've got a heat sensor, it's always going to capture the temperature, the pressure, and the humidity. We'll always have those three things for capturing the heat. If we're capturing wind, we'll always have the speed and the direction. And if we've got rain, a rain sensor, it's just rainfall. Each location might have just one or two or even all three of these. You might capture heat, wind, and rain at one location, but if you are a location, let's say it's somewhere that just captures wind and rain, you will always get the speed and direction and rainfall. Okay, so we've got three groups of optional values. So the question here is, do we just have one giant table to capture all the readings and make all these things nullable? Because of course, one location might only have heat readings, one might only have rainfall readings. Do we make all of them nullable, or do we have separate tables for each group of data? So for heat, like I say, we've got temperature, we've got pressure, we've got humidity as well, so that we can declare them not null for each group of data. Okay. So, like I say, I'll just kind of recap that, give you a second to digest, think about what I've said, come up with your choices, decide what we're going to do. Like I say, we've got three types of sensors: heat sensors, which have temperature, pressure, and humidity; wind sensors, which have wind speed and direction; and rain sensors, which just have rainfall. Each location could have just one of these sensors, could have two of them, could have all three. However, so um, if we are capturing heat data, we're always all going to capture the temperature and the pressure and the humidity, right? So within each of those subgroups, there's a collection of attributes we will always get. Okay. So the question here is, do we just have one giant table for each reading? There's a row, and potentially we've got a whole bunch of null values, right? If we're just capturing rainfall, all those other columns are going to be null all the time. Or do we have a separate table that just stores rainfall with a not null constraint on it, separate table for wind readings, a separate table for heat readings, and things like that? What do we think? Nullable cols or separate tables? To normalize or not to normalize? That's the question, right? Someone saying I hate nulls. So was that? Is that an argument in separate tables? This is always a tricky question. I would go for nullable columns in the same table with check constraints to ensure valid data. So why would you do that? Depends on how you want to analyze the data. If you do many analysis across the three groups, then one table, otherwise separate tables. So if you're always analyzing all the information at once, one table. If you're just comparing heat data, then separate tables. Is that what you're saying? Yeah, that's a fair argument. Forgot to mention that same table provided total number of columns in the table are relatively less. I'm not quite sure. I'm not following you quite there with that. Do we have analytic questions like the average temperature during rainfall? That's a good question. This would influence my decision more than nullability. So basically, do we have analytics that go across the types of data we want to get? That's a good question. I hadn't really thought about that. Let's just say we don't know that we're going to. We don't. It hasn't been given to us as a requirement, but requirements involve. There's a good chance we probably will need to do something like that at some point, right? We're not expecting to need to do that kind of reporting, but who knows? Things can change, but we may need to, right, at some point in the future. Separate tables sound like a lot nicer design, and only in case there is a performance problem where I go for a single table. Why would there be a performance problem with separate tables? So, more votings for hating nulls here. Um, so normalize, not so wise. This, yeah, okay, so we've got that. Lots of people not disliking nulls, so I'm guessing going for the separate tables rather than nullable columns. But it's, like I say, a good point about do we need to do analysis that crosses domains or crosses types, right? You might want to keep a single table to keep timestamp data together, but database design stipulates the other. Or database design, why does database design stipulate the other? I'd go for an extra column of type JSON to get all that information. For aggregations, the in-memory option would help very, very much. Okay, yeah, that's another way of solving it, right? Rather than just having separate columns for each, we just have one JSON column and stick everything in there and just let handle it as is. So we don't have any nulls, and just each sensor gives us what we need, and we convert it. Chances are it gives us it as JSON anyway, or we can easily JSONify it. That's another approach we could take here. That's a good point. Uh, any other comments on this or thoughts? Let me get through some of these. Okay. It's a data warehouse-like system. So temperature, wind are the facts, sensor location are the dimensions. So one table makes sense. Yeah, I mean, they say these are all facts about a location at a point in time, right? So yeah, typically in a data warehouse, you'd have one fact table. You might have multiple, but a fact table is about something that happened at a particular point in time, right? So it's probably yes, it is closer to the data warehouses than transactional processing. Certainly, we're just ingesting data and then probably doing lots of reporting on it later. Okay, we say JSON. I hate JSON even more than I hate nulls. Ooh, go with separate tables. Wow, why do you hate JSON even more than nulls? Right. Overall weather is actually determined by all three distinct weather factors, so it's better to keep all the three weather-related data in one single table, right? Yeah, there are maybe some correlation, or certainly when it comes to predicting weather data, you probably want to factor all these things together. So you're saying you want to have kind of cross type analysis, um, and so need to think about that. Yeah, that's a good point. Alrighty then. So I think we need to. So we fit in. I'm going to open the voting. They say if you've got more comments on that, um, feel free to keep typing. But the vote's open, so let's get those going. Oh, this is one. I think this is the closest one yet, actually, from based on how the voting's going so far. Um, so let's see. I think I saw everyone's comments there. Do. Okay. So it's still pretty close, right? So if you've got a burning thought about one way, if you have strong preference one way or the other, now's your time to make your say because there's not many votes in it. Okay, not everyone's voted yet, so I'll give it a few more seconds. I'm not seeing any more comments or questions, suggestions on this coming in yet. Okay, so we would love to know which you would vote on this. We'll say which I will vote later, right? We'll do that at the end. But let's do this. Okay. So I think I'll give you a few more seconds. Final five, four, three, two, one. End poll, share the results in separate tables. Actually, it was really close on this one for quite a long time. It was only nullable columns. Separate tables only edged it out right at the very end there. So separate tables pulled it out at the end there. So all right. So we've got our choices there. So that's all the decisions we're going to make. Let's build the schema. Right. So let me just make sure I've got it. Let's just check I am connected properly. That works. Yep. So we went timestamp. We went tables. We went cascade, and we went materialized. Okay. So first thing we want to do is create the sensor table itself. Right. We just got some basic information about where they are. So we had separate tables. Right? Yeah. So I need to uncomment the on delete cascade, and I'm gonna comment out the timestamp. So we've got all our comments here. Now, someone was mentioning like vaguely make sure all the group of nullable columns are not null as a group. We can use constraints. You can do this little NVL2 trick to make sure either all or none of them are null. Um, Very useful when you've got lots of these, so you don't have to do lots of ands and ors. Basically, if I forget which way around, if it's null, it's one. If it's not null, it's zero. I forget which way, but if it's three or zero, so you can check that they're either all set or not none are set. So let's just do that. So let's create our sensor readings table. We need our on delete cascade for our heat readings. Now notice we can make more not null. That makes things nice and easy there. Wind readings on delete cascade. Um, One thing to note, little thing, the foreign keys I'm declaring here. Notice I haven't actually specified the data type for the sensor or the reading data type, and I've made the foreign key. This means they automatically get the same data type as the columns in the parent table. So quite useful for this demo where I'm going to have to change things date or timestamp. But actually, I think generally useful because it's you almost always want the child column to have the same data type as the parent column, right? Just a nice little simplification. We don't need to specify the data type there. Let's load some sensors in. Now, if we'd gone for a single table insert and we were loading multiple things in, we'd have potentially like all these nulls, or if we wanted generic ones, that could get a bit fiddly to do. Um, so in 23.9.9, no, 23.9, right? We added the ability to do column equals update like set syntax for inserts. So we could do this. So we could optionally specify the values for each one, each row, rather than have a bunch of nulls here. It's not what we're doing here, so we can skip over that. Also, if we have a query, we can do insert by name, match the columns in the results, select results to the table. We're going to skip over that. We have got separate tables, so we can do multi-table inserts. This has been around, multi-table inserts have been around a very, very long time. I don't know when, but a very long time. But these also have the insert set syntax as well. So we're going to run our query to load some data in, and you notice I've got an error here. Integrity constraint parent not found. So I'm loading the reading in and then the child tables. Okay. Um, it's actually kind of non-deterministic which order these will be loaded in. Okay, so we needed to set the constraints deferred. So there we go. We've got all the rows inserted. So a detail to be aware of if we've got multi-table inserts like that. But the key thing here is we can load all the information in with one insert, even though we've got separate tables. All right, so let's check the data. I need to comment back in. We say something no one really mentioned is if well, we kind of mentioned, I guess, if we do want to see all the data, we need to join them all together, right? I guess we kind of implicitly mentioned that, talking about reading across things. Now, we want to delete a sensor. We want to delete sensor one, and we made it on delete cascade. So fortunately, we can just do this, right? Bang, we're done, right? That deletes everything, which you can say makes things nice and simple. But as someone said, this is kind of dangerous. If we accidentally delete the wrong sensor, oops, it's automatically gone and potentially would wipe things out. So you do need to be a bit careful from that. But it does make things easy if we know we definitely want to remove things. All right. So, um, these kind of joins and stuff, we have to write these joins and we have to worry about multi-table inserts. What we could do instead to kind of simplify things is create a view which has all these joins for us. So we can query it just like a regular table. We don't even need to know it's actually joins underneath. So that makes a nice simple SQL. Good for querying, not so good for DML because if we have to delete something, it won't let us do it. Can't delete from a view. Can't modify a non-key preserved table because we're trying to write to many tables at once. It's a bit of a faff, right? Now it is possible. Like I say, we could create our own instead of insert, update, delete DML triggers to redirect things for us. But that's a bit of a pain. I don't want to do that. You probably don't want to do that either. Luckily, there is something we can do which emulates this functionality without us having to write a lot, and that is JSON relational duality views. So these are something we introduced in the initial release of 26 AI database a year and a half ago. Um, we can create our JSON relational duality view. So we get our sensor readings, and then we can select each table and have it as a nested object within there. If we didn't have separate tables, we could still have those as separate objects. Now notice got what seems like the same columns many times. That's because we've got to select all the primary key columns of the tables we want to do this insert delete, right? So by marking with insert delete, for the database to do that, it needs to have the primary key columns there. So we create our sensor data, and now we get each reading as JSON data like that. Um, Nice thing about this is we can now load data in as JSON. So someone said they didn't like JSON. I mean, okay, fair enough. But we might still need it. They say with the sensor readings, we might get it as JSON. Do. Oh, yeah. I need to set my constraints deferred again. I'm inserting sensor 0, which doesn't exist. Um, Key thing here is I can just insert my JSON object, in it goes. I don't need to care about what the structure, relational structure is. The database resolves it for us. Essentially, it's created those instead of insert triggers. The exact structure of the JSON might vary a bit, but we've saved ourselves a lot of coding potentially here. We don't need to know what the underlying table is, other once we've created this JSON relational duality view. So there's our new sensor. We can delete it. However, this is the sensor readings, right? Our um, sensors is the root to our root of the JSON duality is each individual reading, not the sensor. We wanted to delete a sensor in all its readings. Okay, so we've still got it there. That's not what we want. We can get around this. We can create each one, we can create the duality view as, and then have an array of the readings for each one. So we do that. We've got each sensor as the root. We've still got the insert delete things there. We've now got a row per sensor and an array of all the readings for each one. Okay, so it's a different way of representing this data. The advantage of this is, let me just uncomment this out. So I would have had different structure slightly if it all been one in table, because we wouldn't need to select or also include the primary key columns. They're just there once. So we put that in. So we've got our sensor data. We've got our new thing there. We delete it, and it's gone. Okay. So because we got our root. So the thing of duality views, we don't need to care about the structure of the underlying tables, but we do need to care about the root, and we might need different duality views about what we're going to do. Nice thing is, however, it does all the DML, like does all the magic for us, and deletes everything. So we didn't need to have on delete cascade foreign keys in this case. It actually cleaned it all up for us without that. We don't have time to show that. Maybe another day we can catch up, or you can prove to yourself. I'll share the scripts. I'll load them on my GitHub later, and you can see this for yourself in action. All right. So that's the different structures, and we can see how things work here. So we can see we've looked at different dates versus timestamps, and as someone said, they have different logic, right? Date minus date is numbers, timestamp minus timestamp is an interval, right? And with a timestamp, we've also got fractional seconds. This impacts our formula. Like I say, we wanted to calculate the time difference, how many seconds between them. If this was a date, we could do something like this. But if we do that with an interval, that's not right. We've multiplied our interval up by this number of seconds in a day. We've got 687 days between the things. That's not right here. So actually, the formula here for timestamps is a bit more involved because we need to extract out the minutes and then add on the seconds. We've got a slightly more complicated formula here. So a lot of situations, we can convert date to timestamp and the database handles it. When it comes to these difference calculations and we want to convert those, we do need different handling here. It's just something to be aware of. Notice I've got the window clause in 21C, so we can reuse our window. Just a little simplification there. All right, so we had our rolling 1 hour, oh, I said 1 hour rainfall totals. So we're getting our running average. Now we can say order by time and get the hour preceding. If this is a date, this works for both dates and timestamps. So we can get a running total of rainfall for each sensor. However, 1 hour, 1/24th of a day. Um, this only works for dates, right? It does not work. It doesn't work for timestamps. So again, there are situations where you just need to be aware the logic, the arithmetic is slightly different between them. So and have your code work appropriately. And as I say, only timestamps support time zones. We can say timestamp at time zone, but we can't say date at time zone. This statement always errors. Okay. All right, temperature conversions. Now I'm going to got a function. I'm putting a sleep in just to make it take a while, just to kind of so we can see. Someone said this is actually really fast. This is just to make it take a while so we can see the real difference here. And we went for a materialized column. So when I add this column to the table, we are going to run that calculation on all the rows in that table. So you see, ding, 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 ding. It's going to take a little while. So just over 8 seconds. Um, However, because we have now calculated it, this query is nice and fast. We've got the result. If we'd made it virtual, then it would have been the other way around, right? So for write once, read many, materialized is probably the right choice unless we needed really high throughput. Okay, so that was the demo. We're getting close to the hour. Someone was asking what I thought. I'm going to recap, give my choices, and then we'll close out for today. Okay, so we saw dates versus timestamps. Different precisions. Timestamps have time zone, dates don't, and there's different arithmetic for them. Personally, I'd say you'd use if you need time fractional precision or time zones, you have to use a timestamp. Case closed, right? However, date is generally a little bit simpler, at least in my opinion, right? So if you only need if you only need second precision, usually I would go for a date. Timestamp if you need extra logic or extra precision. No action versus on delete cascade. You say if we had no action, I would have had to I had all those statements, I chopped them all out. You have to write them yourself. The advantage is you've got full control. You can't accidentally wipe stuff out without realizing it. On delete cascade, nice and simple, but you could have unexpected actions. However, I would say here the thing to think about is look at duality views because it does all that logic for you. You've still got the ability to go into SQL yourself if you need to. So whichever of these, we couldn't really see it because we don't delete cascade, but like I say, I'll share the scripts. You can prove to yourself. We could have made those foreign keys no action, and duality views would have just handled the deletions for us. Okay. I think you did need to make the foreign keys deferrable to ensure it works, but you don't need to make them on delete cascade. So this is a nice way to simplify your data access. Virtual versus materialized. Is it on read? Is it on write? What do you think? Again, this is very much it depends. Um, I would say, however, generally you'll want materialized. You'll use for virtual if it's really high ingest, you're getting lots of concurrent inserts. As someone said, although we're only getting readings every 10 minutes per sensor, we could have millions of sensors. So we could actually still have thousands, thousands of inserts per second. Maybe that overhead of materializing it on insert is still too big a bottleneck for us to kind of process this. So if you've got really high ingest, or if you read rarely, it's unusual, but some systems use virtual. But generally, I would go materialize. Most use cases lend themselves to materialize more. Certainly, this one would tend to. Nullable calls versus separate tables, right? They say with nulls, we've got null handling, but we've also got fewer joins, right? We didn't cover that much detail, but we've also got wider tables. and kind of deeper tables as well, potentially. For every thing, we've got lots of rows. With separate tables, for each sensor, we've got a subset of the data probably. We minimize nulls, but we probably will have more joins. But the tables themselves are also skinnier. If we're just reading rainfall data, we're reading just much less data. So all other things being equal, the query will be faster. I would generally tend towards separate tables if they've got a group of data, which is always going to be set, right? Now, if it was kind of sort of optional, sometimes we would get nullable stuff. We didn't know. Each sensor it was kind of random whether or not what was not sent and not sent. I would probably go for nullable calls just because we can't enforce the constraints. In that case, I might even go for JSON, but I would tend to separate tables, like I say, unless performance or other things meant otherwise. We could always build materialized views and stuff to reconstruct the joins if we need to. And probably for this kind of analysis data where we're aggregating lots of rows and computing across it, we probably want materialized net views, something we'd probably look at anyway. So I think just to kind of finish up, there's lots of choices here. There's lots of trade-offs. What do we prefer? Which is more important to you? It depends on your use case and your situation. Do we need faster writes? Do we need faster reads? Do we need more space? There's always a bit of a trade-off of which is better or worse. And it's very use case dependent. You need to think about this. Whatever your priority, whatever you think about, Oracle AI database has a solution that will support it for you. But I think, increasingly as we move to the AI world, we're generating this stuff. Yes, you might have your AI tool generate the code. You still got to think and review and say, is this really what we want? Does this support our use case? Is this the optimal solution for us in our scenario? So you can spend more time thinking, hopefully, about these higher order things and choose the best solution for your environment. All right, with that, all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something. As I say, I'll see you. Actually, it's just over 3 weeks now. I'll be covering everything actually, all the SQL features since 23 AI was first released up to last month. So join us to kind of see what's changed there, learn about what AI database is all about. Um, I really hope to see you next time. Go out, enjoy the rest of your day, and I'll see you next time. Goodbye.